And look at section 8.1. The first thing I would like you to realize is that you cannot have a zero in the denominator. That means that this is that means that this right here is a fraction. So there's no zero in the denominator. So P or Q of X cannot equal 0. So suppose you had 3 over 0. That's a no-no. So no. Okay? Number 1 says graph f of x equals x minus 1 over x minus 3 is given. You're looking at the behavior of the functions as it approaches the horizontal and vertical asymptote. This right here is going to be the horizontal asymptote. This right here is going to be your vertical asymptotes. Your vertical asymptotes are always in the denominator. Your horizontal asymptotes are based on a ratio. We'll go over that in a little bit. So, as x approaches infinity, that means it wants to know what's happening at the top of the function. Where is our function going? So as our function starts, where does it go? Does it keep on going to infinity? No, we have a barrier right here of your horizontal asymptote at 1. So we're going to put 1 there. So then if you have something that's happening, again, we're going from top to bottom and bottom to top. I'll let you just stick with the bottom because it's just easier to go through. So if you have x approaches negative infinity, so we have negative infinity. Where does it start? It starts at 1. So then you put 1 here again. Then you have the right. As x approaches 3 from the right, this 3 plus means right. So then you're going like this. What happens? It stops at, right? It stops at that 3. So what happens from 3 to the right? It keeps on going to infinity. And then if you have 3 from the left, what happens from the left-hand side of the 3? That's this way, or you can go that way. It's going to negative infinity. So for number 2, we're looking for what's called the restricted values. The restricted value is also going to be the vertical asymptote. So these two are equal to each other. For the first one, restricted values means only denominator. So for number 1, we're just looking at the denominator, and it's going to be x minus 5 equals 0, x equals 5. Your vertical asymptote is also x equals 5. This is going to be your restricted value. The next one is going to be a little bit more difficult. We're not supposed to really go over it, but let's go ahead and talk about it. So the first thing I want to do is I want to factor. I'm going to factor the denominator, and I'm going to, let's see. The factor of the denominator is going to be x minus 3, x plus 1. When you factor, please remember that when the numerators, like the whole expression, cancels, that you're left with 1. So our new equation is going to be 1 over x plus 1. So then we take the denominator and we say x plus 1 equals 0. Solve for x. And that's going to be our restricted value. And our vertical asymptote. Vertical asymptotes are always whatever the x is equal to in the denominator. Should be a 1. Those are your solutions right there. Last one, we're gonna factor the denominator. I'm gonna get factor by grouping. So this is gonna be x squared, x minus 1 minus 25, x minus 1 equals 0. So then I get x squared minus 25, x minus 1 equals 0. You got to solve for x here. X squared minus 25 equals 0. X minus 1 equals 0. This becomes x squared equals 25. We add 25 to both sides. Take the square root of x squared, square root of 25. X equals positive and negative 5. And then this one, x equals 1. So we're going to talk about restricted values first. Restricted value is going to be x equals negative 5, 5, and 1. Our vertical isotopes is also going to be the same. X equals negative 5, x equals 5, and x equals 1. That's our solution for that third example. Domain, so domain again automatically means denominator. And for your domain, you're going to use union. So remember, it's going to account for the gap. So x minus 9 cannot equal 0. X cannot equal 9. That means that our domain is going to be negative infinity, comma 9, union 9, comma infinity. Domain of B, you take the denominator, say it cannot equal 0. So x minus 5 cannot equal 0, x equals 5. That's going to be where we have our union, everyone. So negative infinity, comma 5, union 5, comma infinity. Domain of that rational expression or rational equation, excuse me. That's it. How we determine horizontal and vertical isotopes. We already did vertical, so now we're going to do horizontal. This is going to be based on exponents. So based on exponents. So you have a fraction. We're looking at the exponent of the top versus exponent on the bottom. So these are the cases. Case 1, case 2, case 3. So this is the N and this is the M. So top greater than the bottom. Then there's no HA. HA is your horizontal isotope. For the second one, let's see what it says. The top is less than the bottom. So that means your y equals 0 is your HA. So this is 1, 2, and then the third case says that they're the same. So the top exponent equals the bottom exponent. And that means it's going to be a ratio of these are supposed to be the coefficients of the leading term. Okay, so let's look at these. These are already graphed for you. You can graph on Desmos. Let's determine what case these are. This first one, we're only looking at the leading terms or what's in the denominator. So this is going to be exponent of 1, exponent of 2. So this is 1 and 2. Which case is that? 1 is less than 2. So that's going to be a case 2. So this is a case 2. And case 2 says y equals 0. So your, horizontal isotope is going to be y equals 0. Number 6, we have 3x squared divided by x squared minus 9. Let's look at the numerator and the denominator. So This is 2 and 2. Those are equal to each other. So now we look, this is a case 3, and we're going to look at the ratio of A over B. Let's talk about this. This is A, and then the number right here is B. It's assumed to be a 1. So now you have, excuse me, rewrite that. A over B. So now you have 3 over 1. And so your horizontal asymptote is going to be equal to y equals 3. And you can see it down here. Right here at 3, nothing's happening. The graph doesn't cross. Then number 7. What is this? Number 7. Where the top is greater than the bottom. So it's 3 and 2. The top is greater than the bottom. This is going to be a case 1. That means that there's no HA. Okay. So there's none. So you're not saying that y equals anything. There just isn't. We call this an oblique. To graph f of x equals 1 over x minus 3 minus 1. Okay, so the first thing we have to do here is we have to think about what transformations we have. We have a horizontal shift. We have a vertical shift, vertical asymptote, horizontal asymptote, and then we have intercepts, right? So we have x and y intercepts. Or we can just look at the graph, right? We put in decimals. So let's do this the longhand. The first thing I want to do is I want to take this function and go ahead and make a common denominator. So the way that it is fine, but we still need to have a common denominator for the whole thing. So 1 over x minus 3 minus 1. My common denominator is x minus 3. Here's what we're going to do. We're going to recall that this right here is over 1. And you want to put this whole thing in parentheses. So our common denominator is x minus 3. The first term is fine. The second term is what we want to multiply by. So then we get 1 over x minus 3 minus 1 times x minus 3 divided by 1 times x minus 3. And then we're going to get 1 minus. We're going to distribute that negative. There's going to be x plus 3. X minus 3. So now together it's going to be negative x plus 4 over x minus 3 equals y. So now we're ready to talk about the transformations. So the transformations that you have here are going to be based on like the cases, the denominator, a vertical asymptote, the horizontal asymptote, the x-intercepts, all that. So in this case, let's talk about horizontal shift. So that was a horizontal shift 3 units to the right. So you look at the denominator, so it's x minus 3. So it becomes the opposite. So this is right 3. It's this part we're looking at here. And then you have the vertical shift. Vertical shift, at this point, you don't have anything happening, like to move it up or down. So that's pretty good. And then the reflection, you don't have one. Okay, now let's talk about the vertical asymptote. The horizontal asymptote or the vertical asymptote is going to be based on the denominator. So vertical asymptote means x minus 3, x minus 3 equals 0, x equals 3. That's your horizontal. Vertical is be based on cases. I'm sorry. Yeah, vertical, horizontal. Horizontal is based on cases. You want to take the new expression, negative x plus 4 over x minus 3. We're wanting to isolate the leading terms. So this has a power 1 and that has a power 1. So the top equals the bottom. 1 equals 1. So that means we have a ratio of our coefficients a over b. So this is going to be, just make it clear, 1 over 1. Negative 1 over 1 equals negative 1. Your horizontal asymptote is y equals negative 1. And then we need to talk about the intercepts. We're doing all this to sketch our graph. So we've gone through horizontal asymptote, horizontal shift, vertical asymptote, horizontal asymptote, and now the x and y intercepts. It's a lot. So x-intercept, I can't see that. It's going to be where your y equals 0 and your x, you're not sure. So let's do, on the original equation, solving for x. So we have 1 over x minus 3 minus 1 equals y. We have 0 equals minus 3 minus 1. Add 1 to both sides. So we're going to get 1 over x minus 3 equals 1. You can do the reciprocal, so multiply both sides by x minus 3. These two on the left will simplify. And on the right, you're going to get 1 equals x minus 3, x equals 4. That's your intercept. And then for x-intercept. So then we bring this together and we go 4, 0. When you do your y-intercept, you're substituting x equals 0 and solving for y. So then we do 1 over x minus 3 minus 1 equals y. 1 over 0 minus 3 minus 1 equals y. 1 over negative 3 minus 1 equals y. So that becomes negative 4 thirds. You're adding them together, equals y. 0, negative 4 over 3. Let's make sure. So let's graph this on Desmos. When I look at that, 4, 0, there you go, negative 1.33. That's exactly what it is. And then you have, let's zoom in. You have your vertical asymptote at 3. So it's going to look something like this. Like that. And then it can't go close to the 1. -1, excuse me. And then it goes about right here. And about right here. So our graph is going to look like that. Again, all this is just a sketch. For number 1, now we're going to go ahead and take all those attributes and determine the function. If I were you, I would just use Desmos and see which one matches the scenario. So we're going to type these in. I remember doing these in class. I think the answer was the first one. So let's see what these look like. Remember that it's going to be the x-intercepts in the numerator and the y, no, what is it? X-intercepts over vertical isotopes on the denominator. And then you need the cases for the horizontal isotope. But again, it's something you can observe. So we're just going to type this in, y equals, use the fraction bar. And it's going to be x squared plus 7x minus 12. And then it's going to be x squared minus 2x should be x squared minus 2x minus 1. All right, let's see what we see. X-intercepts, 3 and 4. Nope, that's not it. That's a -3. So automatically that one's wrong. I thought it was that one, sorry. So we're going down to list to make sure that we observe the right thing. Okay, so y equals divided by, I'm just talking about the buttons, x squared minus 7x plus 12 over x squared plus 2x plus 1. Oops. Okay, let's read that one. That one still has x-intercepts that are negative. Let's make sure we typed it in correctly. Oh, maybe not. It's got 3 x-intercepts. This one only lists 2. So that one's not it. Y equals x squared minus 12x minus 7x plus 12. No, it's going to be x squared minus 2x minus 1. Again with the 3 intercepts. It only lists 2. Okay, well, those 2 work, 2 of them work out. Let's look at the rest. Let's look at the rest of these. Those work out. What else can we look at? Vertical isotope at -1. Yeah, that looks about right. Horizontal isotope at 1. Maybe, like right there. And then y-intercept at 0.12. Oh, this is -12. It's not that one. All right, it must be the last one. Let's just make sure. So when you're taking the test, this is just an option for you. As you can see, this problem is taking me a while. Even though I'm communicating with you, I'm still having to make sure that I'm observing the function, that I'm entering, right, that I'm pressing the buttons correctly, reading my list. This has to be it. Okay. But understanding what that list means. 3, 0, 4. No, these are negative. Okay, so the best answer is C. Okay. Any questions? Let me know.